we will show you guys the most easiest way to find inverse matrix. First thing first, there are 3 methods to find it. Firstly, we got adjoint method, where we will emphasize more in this video. The second one is elementary row operation, and also known as ERO. And the third one is by using properties, which is with the formula AB equal to KI. So let's see the overview about our adjoint method. Adjoint method consists of 4 important steps. The first step is to find the cofactor of the matrix. The formula is Cij is equal to -1 power of ij times minor ij. I refer to the row while j refer to the column. The second step is to find the transpose of the matrix to obtain adjoint A. As we know, transpose is equal to adjoint A. Remember that. The third step is to find the determinant. The formula is sum Aij times with Cij, which is A refer to the matrix and C refer to the cofactor. And the last step is to substitute the determinant and the adjoint A that we find to the general formula of inverse matrix by adjoint method, which is 1 over determinant times with adjoint A.
Now, let us see matrix in our daily life. You guys want anything?
I want 2 chocolate, 1 pomegranate, and 3 kaya. I don't like kaya. I want strawberry chocolate and 8 coconut.
Okay, let's pay.
I would like to pay for 14 chocolate, 15 kaya, and 7 coconut. The total is 33.
So guys, from the situation, we can distribute the order into the matrix form like this. And next, we would like to find the inverse of the matrix. First thing first, we need to find the cofactor by using this formula, where I is referred to the specific row and j is referred to the specific column of the matrix, while m is referred to the minor of the matrix. Now, let's say if you would like to find the cofactor of C11. C11 means you would like to find the cofactor of the first row and the first column. And what you need to do is just by substitute this value into this formula. As you substitute, you will get this as your answer, where -1 the power of 1 plus 1 times with m11. Now, how you will get m11 value? M11 is the minor of the first row and the first column of the matrix. So, to find this minor, you need to close the first row and close the first column of the matrix. Now, let's see here. If you close the first row and close the first column of the matrix, you will take the excluded number as your minor. And that's it. That is how you find the minor. And here is the sequence for us to find the cofactor. Back to our questions, we need to find the cofactor of this matrix, right? So just follow the sequence. The first one is we need to find the A11. A11 is what we have done here. So we can just copy it and take it into here. So the next step is we need to find A12. A12, we just need to substitute the value of the row and the column into this formula. We will get -1, the power of 1 plus 2 times with m12. So we will need to find the m12. M12 means the minor of the first row and the second column. And what we need to do? We need to close the first row and close the second column of the matrix. As we close, we will take the excluded number as our minor and put it into here. So the same step we will apply to find the other component. As we find all of the component, we need to calculate for each component. How to calculate it? So we just need to use the common matrix formula, which is AD minus BC. We just need to substitute the value into this formula. As we substitute the value, we need to times with the -1, the power of 2. And we will get the answer is -32. And same step we will apply to the other component. And then you will get the answer like this as your cofactor.
Now, let's go to our next step, which consists of transpose C to obtain adjoint A. So what is transpose? Transpose is interchanging of rows and column. For example, our first row consists of ABC. So to find the transpose, the ABC will be the first column of the transpose. Do you guys understand? If not, I'm going to show the exact example from the questions just now. Our cofactor, the first row consists of -32, 28, and -2. But the first column of the transpose will be the exact -32, 28, and -2. While for our second row of the matrix, 24, -21, and 9 will be the second column of the transpose. And for our last row of the cofactor will be the last column of the transpose, which is 14, -7, and 7. Thus, from the first formula that I have mentioned before, adjoint A equals to C transpose. So the transpose that we got just now will be the adjoint A that we will imply in the formula of the inverse matrix, which is 1 over determinant of A times by adjoint A. So the adjoint A that we got just now will be used in this formula. Now, let's go to our next step, which is finding determinant. The formula of determinant is sum of Aij times by Cij. As what my friends have mentioned before, I refer to specific row while J refer to specific column. So let us move on to our original example. Matrix A consists of 2, 1, 3, 5, 6, 4, 7, 8, 0. So, Aij refer to the original matrix, which is this one. So, which row do we need to choose? Because Aij refer to the row only. So, to make our steps a lot more easier, I would recommend us to choose from row that consists 0. From our original matrix, we can observe that the third row consists of 0. So, I will choose this one. For Cij, we need to follow from the original matrix that we choose. So, if matrix A, we choose third row, so what about the cofactor? Obviously, we need to choose the third row also. So, the sum is by multiplying 7 and 14, the pair, plus by 8 times by negative 7, and the last one, plus by 0 times by 7. So, press the calculator and we'll got 42. Before we move on to our last step, we need to see the properties of determinant. So, the first one, if any row or column contain only 0, the determinant will be 0. For the second properties, if any two rows or columns are identical, for the situation that I have wrote, matrix of A consists of the first row 3, 4 and 2, and the third row have the same numbers 3, 4 and 2. Thus, the determinant will be 0. And for the last one, if matrix B is obtained by multiplying of A, so our determinant will be the same multiplication factors. For example, matrix A, the first row consists of 2 and 3, while matrix B consists of 4 and 6, which is by multiplying 2 and 3 with number 2. Thus, the determinant of B will be 2 times determinant of A. So this is the steps or the properties that we need to remember to ease our journey to find the determinant. Wow, now we have come to our last step, which is by substituting the A determinant and also adjoint A that we have calculated just now. The formula for adjoint method is 1 over determinant A times by adjoint A. So this is the adjoint A that we got just now, and 42 is the sum for our determinant. So by substituting, we will get 1 over 42 times by the value of the adjoint. So how do we want to multiply this with our adjoint A? We just need to multiply it 1 by 1. So 1 over 42 times by negative 32, we will get negative 16 over 21. 1 over 42 times by 24, we will get 4 over 7. And 1 over 42 times by 14, we will get 1 over 3. And so on. So it's easy, right?
Congrats guys, you've come to the end of our study.
So let's recap the important formula that we just learned together just now. First, cofactor. We need to know that the formula is Cij is equal to negative 1 power of I plus j times minor ij. And the second one is adjoint A. We need to know that adjoint A is equal to C transpose. And the last one is determinant, which is equal to sum of Aij times Cij.